All right, everybody, welcome back. We like to get a little geeky here, and today we are diving deep into the world of PCI Express.
PCIe.
Yeah, PCIe, that's right. It's kind of the unsung hero inside our computers, making sure everything talks to everything else at lightning speed.
It's true. It's like the central nervous system of a computer.
Really is. And it's replaced all those older, slower connections, which is amazing. But the demands on PCIe are only getting bigger, right?
Oh, for sure. As technology keeps evolving, we need more speed. Got to make sure everything's secure. Got to be efficient. Squeezing every ounce of performance out of our systems.
Absolutely. And that's what makes today's deep dive so fascinating. We're going to explore two mechanisms that are key to making PCIe even better. Base address registers, bars for short, and ID-based filtering. By the time we're done, you'll have this aha moment about how much is actually going on behind the scenes every time you click, scroll, or game.
I think a lot of people would be surprised. Like, it's magic.
Totally. Total magic. So let's start with these mysterious BRs. What are they all about?
Okay, so bars, base address registers, these are like the signposts within a PCIe device. They basically tell the CPU where to find everything.
Signposts. That's a great way to put it. So the CPU needs to access some data on the device. How do bars help with that?
Well, you see, each PCIe device is given a certain range of addresses in the computer's memory map.
Like a chunk of real estate just for that device.
Exactly. And each BAR within that chunk points to a specific resource on the device. Could be something like its configuration space or its memory, where it stores data.
Okay, so it's not just one big blob of memory. Each BIR points to a very specific function or piece of data.
That's right. And that level of organization is super important for how everything works together.
Now, this is where BAR filtering comes in, right?
Yes, BIR filtering. This is like having a security guard at each of those resources we talked about.
A security guard. Interesting. So how does that security guard actually work?
Okay, so imagine you have a whole bunch of data requests coming in, like different programs on your computer wanting to access stuff on a PCIe device.
Like a busy airport with everyone trying to get to their gate.
Perfect analogy. So each of those requests has to show its ID, right?
Like a boarding pass, yeah.
Exactly. The ID in this case is the address they are trying to access. BAR filtering checks that address against the list of allowed addresses for that device. If it matches a BAR, the request gets through. If not, it's denied.
Denied. No access.
Exactly. And this is really important for security. It prevents rogue programs or malware from snooping around where they shouldn't be.
So it's like each BAR is a lock, and only the request with the matching key gets to open the door.
That's a great way to think about it. It ensures that each program can only access its designated resources. Especially important in systems where you have multiple applications trying to use the same device. Things could get messy without BAR filtering.
Oh, I bet. Data flying everywhere, programs crashing, cats and dogs living together, mass hysteria.
You get the picture.
But security isn't the only benefit, right? You mentioned BAR filtering also helps with performance and resource management. How so?
Well, think about it. If you can filter out all the irrelevant requests, you're reducing traffic on the PCIe bus, kind of like removing all the slow cars from a highway.
Makes sense. Less congestion. Everything moves faster.
Precisely. And by only allowing access to specific resources, you're making sure that the device's resources are used efficiently. No wasted cycles on processing requests that shouldn't be there in the first place.
So BAR filtering is like a traffic cop, directing requests to the right place and keeping things moving smoothly. I love these analogies. They really help make sense of this. Can you give us some real-world examples of where BAR filtering comes into play?
Oh, absolutely. Think about secure systems like online banking.
High stakes.
Very high stakes. You want to make sure that only authorized processes, say from your banking app, can access your financial data. BAR filtering helps enforce that.
So it's protecting my hard-earned cash.
It is. Another example, let's say you've got a complex server setup with multiple PCIe devices, maybe for a data center or something. BAR filtering is crucial for preventing conflicts between those devices.
Keeping those servers humming along.
Exactly.
It's amazing. We never see it, but BAR filtering is doing so much behind the scenes. I'm curious, how does the filtering actually happen at a technical level?
Okay, so this all happens at what's called the transaction layer of the PCIe architecture. It's basically a checkpoint for all the data requests. Each device has its own pre-configured list of BRs.
Like their VIP list.
Exactly. So when a request comes in, the device compares the target address to its list of BRs. If there is a match, bam, access granted. If not, sorry, request denied.
Sounds very efficient. So each BAR is a 32-bit memory location. And it doesn't just contain the address, right?
Right. It also includes information about the size of that BAR region and other properties, kind of a full description of the resource it's pointing to.
So it's not just a simple pointer. It's more like a detailed map.
Exactly. And this is where it gets interesting. There is a limited number of BARs per device, typically only 6.
6. That's it.
Yep, 6 BRs to manage all the different resources a device might have. It really shows how important efficient resource allocation is.
Wow, yeah, 6 signposts that point to everything. Okay, so we've covered BAR filtering pretty thoroughly. Now, you mentioned another filtering mechanism, ID-based filtering. How does that differ?
So BIR filtering, that's all about addresses, where you're trying to go. ID-based filtering adds another layer of security by checking who's making the request.
So it's not just where you're going, it's also who you are.
Exactly. This is particularly important in systems with multiple devices because you want to control which devices can talk to each other.
So device A might be allowed to access resource X, but device B is blocked.
Exactly. You get granular control over communication between devices. It helps prevent unauthorized access and can even stop malicious devices from spreading malware.
So it's like checking a device's ID card before allowing it to interact with anything else.
Perfect analogy. It's all about adding layers of security and making sure everything is tightly controlled.
Combining BAR and ID-based filtering, it's like Fort Knox in there.
Pretty much.
I have to say, it's really mind-blowing to think about these invisible mechanisms working constantly to keep our systems secure and running smoothly.
It really is, and it's a testament to how much PCIe technology has evolved, always pushing the boundaries of performance, security, and efficiency.
Absolutely. So next time you're using your computer, just take a moment to appreciate all those gatekeepers and checkpoints working tirelessly in the background thanks to BAR and ID-based filtering, a hidden world within our devices making sure everything works seamlessly for us. And that brings us to the end of our deep dive today, but here is a thought to leave you with. As our systems become even more complex with more and more devices, how do you think these filtering mechanisms will evolve to keep up? Thanks for joining us.
See you next time.